Okay, now first of all, let's try to understand what is critical angle. Okay, because to understand total internal reflections, you must know what is critical angle. The critical angle is the angles of incidence in an optical denser medium for which the angles of refraction is 90 degrees. Okay, now what does this mean? Now you see, if we have a light ray, we use this semicircular prism, semicircular prisms. The reason we use this semicircular prism is if the light ray points towards the center of the circle, then it will not be refracted. It will straight away go in. Okay, it will not be refracted. Okay, that's why we use the semicircular prism. So this is less dense, then it go inside, become denser. Now, when the light ray moves from a denser medium to a less dense medium, it will be refracted away from the normal. Suppose it goes straight forwards, but due to the refractions, it is refracted away from the normal. This is a normal, it will go further or far away from the normal. So this is a refracted ray. Okay, this is usually what happens if we increase the angles of incidence. This is the angles of incidence. This angle here is the angles of incidence. So if we increase the angles of incidence, so you have a light ray like this, okay, then the angles of refraction also increase. So you increase the angles of incidence. Initially, the angles of incidence is this. Okay, now you make it bigger. This is the angles of incidence. So the angle of refraction will also increase. Okay, and you increase again up to one point. Okay, up to one point, the angles of reflections, angles of refractions are RA, refractions. So the angles of refractions become 90 degrees. Okay, because when you increase this will increase, and the maximum angle can be reached is 90 degrees. So you increase up to one point. Okay, the angles of refractions become 90 degrees, where the light ray is refracted parallel to the plane. So this is the maximum angles. This is the maximum angles where refractions can occur. Higher than that, then there will be no more refractions. Okay, smaller than these angles, yes, you have refractions. Okay, like this. Okay, but if the angles are bigger than this, there's no more refractions. If you move the light, go up, no more refractions. Okay, so this is the maximum angle where refractions can occur. So these angles when the angles of refraction become 90 degrees, and this is the maximum angles where refractions can occur, this is called the critical angle. It's called a critical angle. So it's the angles of incidence. This is angles of this is incident ray. So this is angles of incident. This is a refracted ray. This is angles of refractions. So this is the angles of incident in an optical denser medium. It must be inside the optical denser. It must be denser. Okay, it cannot be less dense. Okay, because if the light ray is from less dense to denser, then no critical angle. It must be denser to less dense, then only you have critical angle. So angles of incident in an optically denser medium. Okay, where the angles of refraction become 90 degrees. Okay, so that is critical angle. Then how about if we keep on increasing the angles of incidence? Okay, we move it upwards. So what will happen? Okay, now if you move it upwards, okay, suppose that this is the angles of critical angles. Okay, if the angles of incidence is this one, this is the angles of incidence. If the angles of incidence is bigger than the critical angle, no more refractions, but 100% of the light ray will be reflected. So you see, this is refraction, but if the angles of incidence is bigger than the critical angle, so no more reflections. So no more refractions, 100% of the light ray will be refracted, and we call this total internal reflections. When the angles of incidence exceed the critical angles, then total internal reflections occurs. Okay? So that is total internal reflections. Critical angles and total internal reflections.